Join me as I explore these two videos explaining the amazing adaptations of anoles in city environments. These lizards have adapted rapidly and might be an example of purposeful evolution. Purposeful evolution happens when genetic changes are influenced by environmental factors. Darwinian evolution is different because it relies on blind mutations that can't involve environmental factors unless the genetic information already exists for natural selection to test. The two videos cover mostly the same aspects of the anoles adaptations in cities. Links are in the description below.
With everything we know about anole evolution, a lot of people want to know, are anoles still evolving today? And they mean in nature, outside of these experiments we've done on small islands. Everything we know suggests that anoles should still be evolving.
More than 400 species of anoles throughout the Caribbean, Central and South America, and the southeastern US. That diversity has made them an unlikely hero in the science world because of their remarkable ability to adapt to different environments. Biologists like me have studied them for decades. One thing we're still trying to answer is how these lizards are evolving to thrive in yet another major ecosystem: cities. It turns out these scaly city slickers are adapting to urban life in some really surprising ways. I'm Shane Campbell-Staton, and this is Human Footprint.
The expectation of anoles' ability to evolve in a novel environment shows the predictive power of purposeful evolution. New environmental pressures could affect the emergence of appropriate mutations for a purposeful process, while this is impossible for an undirected process as is attributed to Darwinian evolution.
Kristen Winchell is an expert in urban evolution. She studies lizards called anoles, which live all over the American tropics.
I was looking for a species that might be adapting to urban environments. Came across anoles and started reading about their rich evolutionary history and rapid change after you modify the environment. I just had this moment where I was like, if this is happening, it's in these guys.
Once you know what you're looking for, anole adaptations can be easy to spot. You see, species that live in different habitats have different traits. Big toe pads that help them stick to leaves in the treetops. Long legs that allow them to run fast on the ground. Short legs that help them climb without falling on the tiniest twigs, and so on. Kristen's question was, which of these traits, if any, would help anoles survive in the city? Kristen and I studied the Puerto Rican crested anole. Step one is to find out whether urban and forest anoles are different from one another.
We measure with a digital x-ray all the bones in the body, and you can see that they have these enlarged toe pads on the fore and the hind feet. And so if you were to zoom way in on those, you'd be able to see these tiny scales, and those let the lizards cling to the smooth surfaces.
So for the Puerto Rican crested anole, what did you find?
One of my initial findings was that in the city, the lizards had longer limbs relative to their body length, larger toe pads with more of these specialized scales on the toe pads.
Okay.
These are exactly the kinds of adaptations you might expect to see in cities, based on what we already know about anoles living elsewhere.
They're clinging to things like glass and metal and even painted concrete, which is a lot smoother than anything you find in the forest. And so there's kind of this combined selective pressure on toe pads, making them able to cling better, and limb length, making them able to navigate the structural environment.
The Puerto Rican crested anole was introduced to Miami in the 1970s.
Miami isn't the only place where the crested anole is thriving in a city. On its home island of Puerto Rico, it's also abundant in urban areas. What is it about the crested anole that makes it do so well in cities? Researchers are trying to find out. They've begun to study how the crested anole is adapted to life in the city.
A key question is, how fast can these animals change? And can they keep pace with human-mediated changes in the environment?
Those specialized scales that are on their toes that allow them to grip to walls or to trees. I found that the urban lizards have more of those scales. They're called lamellae, and they also have larger toe pads. And so we think that this might have to do with the smoother surfaces that they are clinging to in urban areas. We've also found that they have longer limbs, in urban areas, but we don't know why these trait differences exist.
These scientists have found the anoles have gained appropriate changes for their new environment. However, they can't be sure these changes have made them better adapted to this new environment unless they are tested against similar anoles from the forest environment. That is what the following tests help discover. They don't know why these trait differences exist because the only process of evolution they know about is the blind emergence of mutations caused by Darwinian evolution. Getting multiple changes that all help in a novel environment should be baffling given a blind process.
The urban lizards were different, but the real test was whether they could actually outperform their forest-dwelling counterparts when facing a uniquely urban challenge.
So I set up a lizard racetrack.
Okay.
And I fitted the racetrack with different surfaces. One was tree bark, one was metal, like fence post metal, and then one was painted concrete. And then I took high-speed video of these lizards racing up the racetrack. What I expected is that the urban lizards would be able to run faster on the concrete and the metal and the urban substrates.
Those are the environments that they were living in.
Yeah, exactly. And so they'd be better at doing that than the forest lizards. What I found, though, was that the urban lizard's just faster overall.
On anything?
On anything.
Even like bark and stuff that's in forest?
Even bark, no matter what angle, no matter what structure we put on the track surface, they were faster. The lizards running on the painted concrete and on the metal ran slower, and they tended to slip a lot more. But so far, across all the tracks, we found that the urban lizards ran faster than the forest lizards.
The tests with different surfaces showed anoles changed in a way that allowed them to adapt to specific factors in the novel environment. Just happening to outperform their forest counterparts with these new changes goes beyond reasonable coincidences for me.
When I, came down and tried out this big idea of our anoles adapting to cities, one of the things that I measured was body temperature and air temperature.
Cities create what scientists call urban heat islands, areas with much hotter temperatures than the surrounding landscape. So a few years ago, Kristen and I decided to find out how urban and forest anoles responded to extreme heat. Sure enough, urban anoles could take the heat better than forest anoles, and we even found a few of the genes that affect heat tolerance. These adaptations aren't unique to any one city. We found the same differences between urban and forest anoles again and again, all over Puerto Rico.
We can think of cities as the big petri dishes that are replicated on a much larger scale.
No two cities are exactly alike, but for anoles, all cities have some things in common. To survive on the streets, crested anoles evolved longer legs, bigger toe pads, and better heat tolerance than their forest relatives. And it happened fast. Some of our urban study locations have only been cities for 30 years. That's evolution in overdrive, even in lizard time.
In urban areas, it's also much hotter. We found that on average, the urban populations had about a 6-degree warmer temperature at the perch site compared to the forest populations. And this difference was also reflected in their body temperature. What we found is across all of the locations that we sampled, the urban lizards were able to tolerate temperatures of around 1 degree higher on average compared to the forest lizards. 1 degree Celsius might not seem like a lot, but for a lizard, this is a difference of being able to be active all day long and have access to all of those mates and all of that food that you otherwise would have to give up because you're hiding in the shade trying to cool down.
The remarkable things about these changes that are occurring is that some species are able to adapt very rapidly within a matter of just a few generations to these new conditions that they're experiencing.
These anoles have even had genetic changes allowing them to function better in the increased heat of cities. This change alone is indicative of a purposeful process. The scientists also commented on how fast these beneficial changes emerged. This is another instance of Darwinian evolution losing its explanatory power for adaptations. A blind force is highly unlikely to cause multiple beneficial changes in such a short time period. It is exponentially more difficult to explain through Darwinian evolution given these adaptations emerged multiple times. This is apparent since anoles gained similar beneficial changes in separate cities.